Hello and welcome to Mr. Benya Has Flipped. This is video lesson number 18, Characteristics of Quadratic Functions in Vertex form. But first we're going to look at the parent function of the quadratic graph, the quadratic equation, and it looks like this: f of x is equal to x squared. The graph looks like this. It's a parabola with a vertex at 0, 0, and the domain of this in interval notation is from negative infinity to positive infinity. It goes forever and ever to the left and then to the right. Now in set notation it looks like this: x such that x is between negative infinity and positive infinity. Now the range is then going to go from 0 to infinity, and that's because in this case you're going to go from 0 here, but then it's going to go up to infinity. And in set notation, it looks like this: y, such as y is between 0, including 0, and infinity. Okay, let's look at an example here. F of x is equal to quantity x plus 3 squared minus 4. Okay, now picture that in your mind and see if we can graph it without looking at the next slide here. So what are some of the transformations going on here? Well, this right here tells you it's going to go to the left 3 and down 4. There's nothing that reflects it across the x-axis, and there's not going to be a vertical stretch or a vertical compression. There it is. That's the graph. Okay, and it did go to the left 3 and then down 4. So the domain is from negative infinity to positive infinity. Okay, there it is in set notation. The range is from negative 4 to infinity, including negative 4. Set notation. The vertex, okay, the vertex is at negative 3, negative 4. Of course, negative 3, negative 4, that's right here, that's the vertex. Okay, so we also want to know what the axis of symmetry is. Now remember, the axis of symmetry is going to cut the graph in half right down the middle. Okay, so it crosses the x-axis at negative 3. Also remember that this number is going to be the same as this number. Okay, it's the same as the x value of the vertex. Okay, in example 2, here is the graph. Now you got to get the equation. So in this case, it's reflected across the x-axis, so there's going to be a negative. It's just a little bit wider, and it looks like it'll be about 1/2. So it moves to the right 5, so there's going to be an x minus 5 inside, and it goes up 2, so there's going to be a plus 2 on the outside. There's the graph and the equation. Okay, the domain of this, looking at the domain, it's almost always going to be the same, from negative infinity to positive infinity. The range, in this case the range is a little weird because it's kind of upside down. Okay, the maximum is up here, so coming up this way here, this is going to be from negative infinity, whoop, and it's going to stop right here at 2. So it's going to go from negative infinity to 2, including 2. Okay, the vertex, once again, is at 5, 2. So the vertex is right here. Alright, stop it. Right there. Okay, axis of symmetry. Here you go. Right here. Whoa. Okay, so it crosses the x-axis at 5. So x equals 5. Once again, this number here and this number here are going to be the same. Okay, we're going to look at something called the x-intercepts now. Where does it cross the x-axis? Those are the x-intercepts. Well, it crosses here and it crosses here. Now you can write it two different ways. You can write it as x equals 3 and x equals 7, or 3, 0 and 7, 0. Y-intercept. Okay, the y-intercept's a little bit different here. It's going to be kind of like right there. Kind of like 10 and a half, it looks like. Where does it cross the y-axis? So it's about 10 and a half, so you can write y equals 10.5 or 0, 10.5. Okay? So, there, that noise means that it's time to close this video. I'll see you in class. You should be working on the SSPs. I sent you the SSPs as an attachment on Remind 101. But either way, I'll see you in class. Okay, work the problems and do at least the first practice quiz. Okay, thank you.